In this video, I'm going to show how to use the cross product function in Affinity Photo's procedural texture filter. The cross product is a function that shows up in physics and mathematics, and it can be applied in computer graphics to generate the normal of a surface. In this video, I don't really have a good example of how to apply this function, and I've searched quite a bit and I haven't found anybody who applies this function in a useful way in generating procedural textures. I know it can be used to create sort of a surface effect, but I'm just going to show how it's used, and then you'll know how to use it. And if you do come up with a good example of how to apply this, let me know in the comments below. So this background I generated using the cross product, and so I guess it could be used for that. So to get started, I'm going to talk about what the cross product is and what it does. The cross product of two vectors A and B generates a new vector C, which is at right angles to both vector A and vector B. And so it's perpendicular to both vectors, and so if these vectors sort of form a plane, then this vector C will be the normal to that plane, so it's perpendicular to the plane. The magnitude of vector C will be given by the magnitude of vector A times the magnitude of vector B times the sine of the angle between those two vectors. Now the sign goes both positive and negative, so if the sine of 0, if the angle between them is 0, then the sine of 0 is 0, and so the magnitude of the vector will be 0. But if the angle between them is 90 degrees, then that will be at its maximum value 1, and this vector will be have its magnitude equal to the magnitude of A times magnitude of B times 1. Okay. At 180 degrees, the sine of 180 degrees will be 0, and then at 270 degrees, the sine of 270 degrees will be minus 1. So there it will point in the opposite direction. It'll be going negative from here. So let's look at how this can be implemented using the procedural texture filter. I'm going to start with a new document. I'll choose XGA, set this to 1024 by 1024 pixels, make sure it's in RGB mode, and create that. And I'm going to fill that with black, and I'm going to add a live procedural texture filter. I'm going to add a single equation and assign it to the 3 color channels, and I'll add a real number input A, label that scale, set that equal to 4, and then I'm going to add a rotation vector TH and set that equal to, this is going to be my coordinate angle. And then I'm going to have another vector, and I'll label that one PH, and that will be my vector angle. So I'll have the coordinate system will be one vector, and then this other angle will become my second vector. Okay, I'm going to go back up to the equation. I'll start with a coordinate vector, and I want these to be rotatable coordinates. So I'm going to start with a variable v equals vec2, a 2-element vector, and this will be rx times cosine of theta, th, minus ry times sine of theta, and then rx times sine of theta, plus ry times cosine of theta. So that will give me rotatable coordinates, and that's the end of the vector. Then I'm going to multiply by A, which is my scaling factor, and then divide by the width of the document in pixels, W. So that looks like that. And now if I go and hold the shift down, I can rotate this to any angle. Put it back at 0. So that's my coordinate vector. So to do the cross product, I need a second vector. So I'm going to create a second vector. This one will be VAR. I'll just call it V1. And I'm going to get that from my vector angle input. And I'll just make it a vec2. And that will be cosine of pH and sine of pH. So my phi angle. So that'll be my vec1 or my V1. And now I want to generate the cross product of these two. So I'm just going to take cross of V and V1, but the cross product has to be a 3-element vector because it's going to generate a 3-element vector. In order to get my coordinate system into a 3-element vector, I'm going to use the function 2vec3, and I'll use that on V. And then I'm going to, my second vector is going to be also 2vec3, and I'm going to apply that to V1. Okay, and then I'll put parentheses on that, and this should generate a 3-element vector, and there it is. And so I can rotate my coordinate angle or the vector angle. Okay, and so I can rotate the coordinate system or my other vector, and you can see this blue color is moving around. Now, I could also add to this, so I'm going to add my 2vec3. I'm going to convert it to a 3-element vector, and I'm going to add my v coordinate to this. And that shows the combination of those. So I can move this, I can rotate the coordinate system around, or I could rotate the vector around, and you can see it moves that coordinate system. So it generates a third vector that's perpendicular to the other two vectors. If I was working in 3D, this would create a plane. The blue color would be perpendicular to the other two colors. So I'm sort of projecting this 3D coordinate system onto a 2D picture and using the color blue to represent that. Okay, so in this video I used two new functions that I haven't covered before, the 2vec3, and so there's a bunch of these 2vec functions. You can go 2vec3, 2vec4, 2vec5, 2vec6, and the procedural textures I think only go up to 6-element vectors, but you can convert from a 2-element vector up to a 3-element vector using this 2vec3 function. Then the other function I use is the cross product, which requires two 3-element vectors and determines cross between those two. Just for fun, you can also add in this elevation rotation vector input, and I'll just call that V, and I'm going to just label this elevation rotation, ER. And so that one is already a 3-element vector, so I could replace my this part, the vec1 function, with letter B. And then I can move this around, and as I do, this other system will rotate around. I'm multiplying by this ER vector. Now I could use this as a coordinate system and apply it to some functions. So if I take this and say this is variable v C for cross product, and then I could use say perlin of vc.x and vc.z, and then put in like 10 octaves and S on, and I'll just use 0.5 instead of S. Okay, so that generates the perlin noise, and then you can sort of warp it with this vector. Okay, so I guess it does give you that capability. You can sort of take one of your other functions and use this vector to sort of warp it. It stretches it out in one of the dimensions, and depending on the, instead of rotatable coordinate angle, I can rotate this, and then I can use this to sort of, you can either go around like that, and when it's at, when it goes to 0, that's when it warps out or goes out to infinity in the one dimension. Okay, so I just wanted to cover that one. It's one function that I haven't covered before. I don't have a great application for it yet. I may think of one in the future, but if you come up with one, let me know. And if you have any comments or questions, let me know down in the comments. I'll try to answer them. All right, so that is the cross product function, and thanks for watching.